Welcome back everyone. This is the bonus section of hands-on shaders and effects in Unity 2019 course, and in this one we are going to talk about ray tracing. Yes, the latest buzzword in the graphics industry. But what is ray tracing and why should we care? I'm glad you asked. Let's grossly oversimplify the physics behind it and imagine a photon particle coming out of a light source. Most likely than not, it will hit many surfaces before reaching a light detector, or your eye. Depending on the properties of the surfaces it hits, the photon will change color after each bounce. Finally, as it reaches your eye, it will have an average color of all of the surfaces it hit. Well, not exactly an average, but we are oversimplifying here. And this is exactly what the ray tracing is. Of course, for optimization purposes, the rays are being shot from the camera, not the light source. The conventional way of rendering shadows, reflections, ambient colors, etc. is just to approximate it with relatively light calculations and shading. While such methods usually produce good enough results, ray tracing is much more accurate and realistic. To be clear, ray tracing is not a new technology. The idea was first described by a German painter, Albrecht Dürer, in the 16th century. It was used in computer graphics for the first time in 1982 by Scott Roth. The technology was evolving ever since and was used in 3D rendering. But until recently, it was impossible to use it for real-time rendering due to the performance limitations. Speaking of performance, ray tracing is still a very expensive process. NVIDIA developed their RTX series with the ray tracing in mind. If you don't have one of those, it might be still possible to run real-time ray traced games on the GPU, but don't expect high frame rates. My laptop has an RTX 2060 and yet, sometimes, I'm getting FPS drops when working with ray tracing in Unity. And yes, Unity does support ray tracing. If you have seen the 2019 Game Developers Conference keynote from Unity, you know that they have been working on the ray tracing for a while. Here is the demo they showed on stage, and one of those cars is real, while another is a 3D model. Hard to tell which is which, right? The fake one is on the left. I still cannot tell the difference. A ray tracing demo was available for a specific version in 2019.2, but with 2019.3 it was implemented in the editor. Keep in mind though, it is still in the experimental stage. For this section, you are gonna need a PC with a powerful GPU, preferably one that supports ray tracing out of the box, like one of NVIDIA's RTX cards with up-to-date drivers. I'm gonna use the alpha version of Unity 2020.1 since the ray tracing in it is relatively more polished and up-to-date. The current ray tracing implementation runs on DirectX 12, so we have to use a Windows 10 machine. Specifically, it requires Windows 10 version 1809 or later. Create a new HDRP project and let's begin. First, make sure that you are using HDRP version 7.1.2 or later. If not, then upgrade it from the package manager. After the update, go to the packages, find the high definition rpconfig folder, and from the runtime folder, open up the shaderconfig.cs.hlsl script. In that file, there should be a shader options ray tracing line. Change the value to 1, save the file, and get back to the editor. From Window, Render Pipeline, open up the HD Render Pipeline wizard and the HDRP plus the XR tab. We want to fix these errors, just like we fixed them in the post-processing section. Click Fix All, restart the editor when asked, and create a fresh scene root prefab. Create a new scene, use the newly created prefab from the HDRP default resources, the XR folder, and both prefabs from the example assets prefabs folder. Set the camera position so we can see the scene. Finally, create a ray tracing environment object from rendering, and the scene should be ready. The ray tracing environment script has a layer mask options for each effect and ray bias settings. The ray bias specifies a bias that HDRP adds to the ray origin along the surface normal. Next, we need to set the cameras. We can turn on the ray tracing for individual cameras using the custom frame settings option, or we can do it from the HDRP settings. Open Edit, Project Settings, HDRP Default Settings, and make sure that the ray tracing option is enabled in the rendering tab of the default settings of our camera category. dock this window somewhere. We will use it a lot during this section. As of now, HDRP does not support the static batching with the ray tracing, so we need to disable it. From Edit, Project Settings, Player, Other Settings, find the static batching option and make sure that it is disabled. And that is it for the setup process.